So welcome to the European CCUS webinar series, which is a co-hosted webinar series with a number of partners from across Europe. We're excited today that we'll be looking at CCUS in the Netherlands, and this session is led by CO2 CATO and Brigitte Jacobs. So it's a pleasure to welcome the director of CATO CO2 to chair today's session and indeed present as well. So I'll hand over to you, Brigitte.
All righty. I think just raise your thumb if you can see my slides. All right, perfect. Good. Now, welcome everyone, and thank you for the introduction, Karis. Yeah, great to have you here at the CATO webinar. Like Karis was saying, it's part of the European CCUS webinar series. And what we are going to discuss today are basically the CCUS developments in the Netherlands. So like Karis already said, my name is Brigitte Jacobs. I act as the director of the CATO network, the Dutch CCS R&D network, and also work with TNO. I think we have a great lineup of speakers for today's sessions. And so after my introduction, I will give the word to Stijn, who works with Energie Beheer Nederland. And he will give us an update of the CCS developments taking place in the Netherlands. I mean, I assume most of you have heard of exciting projects like Portos and Aramis, and he will give us some more details on the progress of these two important projects in the Netherlands, I would say. Afterwards, I'll go a little bit more in detail in terms of international opportunities for Dutch organizations active in the CCS value chain. Basically, we've recently conducted a study where we looked at export opportunities for organizations that are active in the Dutch ecosystem in CCS in terms of exploring export business opportunities, so to say. That will take about 10 minutes, and then I'll hand over to Haije, who works with carbon collectors, and which is an example of a Dutch organization active in this chain and that has opportunities of selling their services outside of the Netherlands. So what he will do is indeed introduce his company, but also discuss opportunities and challenges of CO2 shipment. And then, as always, I will basically close the webinar with a brief wrap-up and some news from the CATO organization. Before I give the word to Stijn Santen, just a few household rules, so to say, for this webinar. So in case of questions, we ask you to write these questions in the Q&A. We will collect questions there. I think they're open and visible for everyone, and we would like to answer these questions at the end of our presentations. So with that being said, I now would like to hand the word to Stijn. Stijn, the floor is yours.
Okay, thank you very much. Welcome everybody at this webinar. I work in EBN, Energie Beheer Nederland, the company which on behalf of the Dutch state participates and develops CCS projects in the Netherlands. And I will tell something about the role of EBN in CCS development. And I would like to start first with how we are positioned. So Karis, if you can show the next slide. So the first part will be about the roles and responsibilities of EBN. So basically, we've got 4 strategic pillars, as you can see in the slide. And so the left one above, that is where we historically started with 40% equity in production of gas, and in a few cases also oil, but usually gas. And over time, that role has been changed in the sense that in addition to producing gas as a non-operating venture partner, we are now also managing the gas storage, because that has been regarded now over time as a really strategic topic. And recently also we got the task of trading in gas. So a few additional tasks. And then if you look to the orange one, geothermal projects, that is an activity which more or less together with CO2 transport and storage started in 2017. And there we have several roles. So we are an advisor to the government, we are a project developer, an investor, and in a specific situation in the Portals project, we will also be an operator. So different roles in these different disciplines, but all linked to sustainability. And then right below energy system analysis, maybe you've seen that once a year EBN publishes its energy infographic with a description of all the developments in energy, CO2 emissions, sustainability measures. And so that is a role which clearly has also a strong synergy with the other activities. In terms of size, we are now with about 300 people. That is quite a strong growth because several years ago we were at a minimum of about 70 people. So from 70 to 300, that is quite a lot. And the largest growth is basically in the area of CO2 transport and storage. In 2023, our turnover was 3 billion euro, to a large extent as a result of our gas production activities. And over time, of course, the portfolio will change and the gas production revenues will decrease, but that needs to be partly compensated by the revenues from the other activities. Okay, so this is about the role of EBN. So let's go to the next slide. We will now describe the Dutch energy system and the role of CCS versus the other decarbonization measures. Here you see a graph, and this is typically a graph which shows that in the Netherlands, the industry, the energy intensive industry, plays an important role. The emissions compared to all the other sectors are the highest. And also the objective, the goals to reach CO2 reduction in 2030 is quite severe. So that explains also why there is so much focus on CCS, because that's typically a large-scale decarbonization method compared to the others. So let's go further to see how that fits. Originally, in the Netherlands, the focus was very much on generation of a lot of renewable power and on subsequent electrification. But what we nowadays see is that both on the feed-in of power, let's say renewable power into the grid, but also the consumption due to plants who electrify or people who want to charge their electric car at home, we see that the grid capacity does not match up with those changes in demand and supply. That's what's called net congestion. And as a result, CCS has become even more important, because if that part of the whole portfolio of measures is not bringing as what it should be, then there's more reliance on CCS. And this is what you can see in the subsequent slide. In the system which we use in the Netherlands to subsidize the additional level of financing that's required to make an affordable business case for industry, that is called the SDE++. In generic terms, that is called contracts for difference. So basically it means that the difference between the EU ETS price and the costs you need to make to operate your CO2 capture plant and to pay also the tariffs for transport and storage, then it turns out that CCS, compared to a lot of other measures, has really the lowest cost per ton. Now, bear in mind, this is a graph from a while ago. There has been a strong inflation, so these numbers are more not up to date, but the relative sizing is more or less the same. So this also explains that if you go for cost-effective measures, then in the Netherlands, CCS is the way to go. If we go to the next slide, here you see the CCS value chain, and it gives a further explanation why we get to these relatively low cost of CCS compared to the other decarbonization measures. We have very favorable logistics in the Netherlands. We have industry clusters where all kinds of plants are closely integrated, and they're also generically close to the sea. And in the sea, in the North Sea, we have many reservoirs which are depleting and which are suitable for CO2 storage. So a situation which you don't see in many countries, having that large storage capacity available, having it very near to industry clusters, and also the flat landscape. It's not ideal for holidays, but having no mountains really helps if you want to construct an infrastructure for CCS. And what you also see is that as these projects are large scale, it takes a lot of time, but in view of their scale, you can bring in the reductions as required. And last but not least, the role of hydrogen. CCS is an enabler for blue hydrogen development, and this is another way of decarbonization. So there are synergies between CCS and different other tools. So if we now go to the specific role of EBN in the CCS project, so we had first the EBN roles, the logic of CCS in the Netherlands. Why do we have EBN? Basically, these are a few topics. First of all, the positive economy of scale. Later on, I will show you a slide with a pipeline. And if you double the pipeline diameter, you can have almost 4 times as much CO2 throughput. So that's what we call economy of scale. But bear in mind, if you design a large pipeline for the capacity of emitting industries that will sign on, that's okay. But if you design in the expectation that not all of them sign directly, but they will come in the future, you make a bet on the future. And if that future is long, then it means that you must be able to survive a long period with negative cash flow due to your capital cost because there's no income yet. And you can only survive that if you have a low capital cost, and that means you need to have a very high credit rating. And that is the situation with EBN. We have a AAA credit rating, and therefore we can do what we did with Porthos, over-design the pipeline so that in the end customers are better off with lower tariffs. But it also means that you need to have the patience and the confidence that those customers will come and that you are able to finance it. So this is one of the logical arguments. There are more arguments, and I already said I would mention the slide. So please, if you can show the pipeline slide. So you see a man in the middle bridging 2 pieces of pipe. The man is not very tall, so you can roughly estimate that the pipeline diameter is around about a meter in diameter. And usually if you ask people, what do you think the capacity will be? It's a 1 meter diameter pipeline. It's onshore, it's not super high pressure. Then most people would say they underestimate the real capacity. And maybe people who followed Porthos, they know that Porthos was designed for 2.5 million tons CO2 per year. So that would be a logical choice for this pipeline. But in reality, it can transport 10 million tons CO2 per year, so 4 times as much. And that means that they can also supply CO2 for other CCS projects like Aramis. And so that is the synergy between the projects, but it requires also the financial capacity to do so. So this is the illustration of the former argument. So let's go to the next one. There is also another argument. As you maybe know, there have been several CCS projects already operating for many years all across the globe, but usually they were developed by an oil and gas company having the assets like a refinery, building their own pipeline, getting an agreement with the government to store in an aquifer, and having complete control on the value chain. And now we're moving into a different direction, an integrated CCS ecosystem. So that big pipeline was an example. So it leads to economy of scale. It also leads to de-risking, because if you have several industrial emitters and you have several storage reservoirs, then the chance that the whole system will fail due to one of them not being able to deliver is much smaller. So it's economy of scale, it's reduction of risk, and also technical arguments, the flow optimization between liquid CO2. I just refer already to the presentation later of Haije Stigter versus gaseous CO2 per pipeline. That by doing that, you can get the right temperature pressure profile. So there is, last but not least, another argument which I would like to make for the presence and participation of public state-owned companies. Usually, and that is also the perception of financing institutions and industrial companies, yeah, we're here to stay. So even without legal contracts, the assumption is that you won't walk away after a few years because you see better opportunities elsewhere in the world. You've got a commitment to the Netherlands, and that is also influencing the risk profile. Okay, so let's go to the projects. First, the Portos project.
And you have another like 10 minutes, okay?
Yeah, thank you.
Okay.
So what we see here is 3 companies which are the shareholders of Portos, EBN, GasUnie, and the Port of Rotterdam. And the role of these companies is that, like I said, in the funding, but also in the fact that they are neutral in the ecosystem. And we will show this in the subsequent examples. So if I can see the next slide. This is the Portos project overview. You've already seen part of the pipeline. Of course, that was above the ground. It will finally be on the ground. That will be connected to a compressor station and then to the field in the North Sea. So quite a big project, 2.5 million tons per year. But if you compare it to the subsequent projects, and I would like to have the next slide, please. Here is the celebration of Portos, and this was with Minister Sophie Hermans last year. And so basically, this showed that, things are getting real. You can see the construction, and that gave much more confidence. So if we go to the subsequent slide, this is the Aramis project. The Aramis project will hopefully take FID in not too long time. And the Aramis project has the synergy that it's connected in transport infrastructure with Portos and builds upon that infrastructure and that experience. But it will be at a certain moment 22 million tons CO2 per year in capacity, so nearly 10 times as large as Portos, and it will also be connected to the countries around us, and that will be seen in the next slide. So here you see the industrial clusters in Belgium, Antwerp and Ghent, which are very close to Rotterdam, and you see also the connection with the German industry clusters. And so that is gradually starting from Portos, creating a large ecosystem with not only CO2 pipelines, but also with CO2 ships, as you can see over here. So here you see the portfolio of the different stores shown in storage capacity. And you see that few of them are maturing. So there are a lot of those storage reservoirs but a lot of them still need to go through that whole process of getting it operationally ready. So if we then move on, here you see more or less a similar slide to what you've seen before, but now the size of the circles indicate the amount of CO2, which is very large amounts from Germany, but also Belgium. And so there is also a closely relationship between the Port of Rotterdam and Port of Antwerp in making this happen via a connection called the Delta-Schelde corridor, which will be built in the future, similar to the Delta-Rhine corridor. So this is how it builds out. Well, let's go to the next one. This has been showing the different roles of the public companies. And I will now go to something which is specific for the Dutch context. That is, as I already mentioned, the SD++ subsidy scheme. And it has worked very successfully to incentivize the market for offshore wind parks. And subsequently, it is now being used to finance a CCS. And what we see is that other countries like France and Germany are following similar methods, similar tools to subsidize their projects. And also the European Commission with the Industrial Decarbonization Bank wants to apply the same mechanism, which is called the contract for difference. And for everybody who wants to see how it works, you can just log in on the website of the SE++ and you can fill in the data and you can get the answer. So it's very user-friendly. So that will bring me to the conclusions. So Porthos has been the catalyst for the Dutch CCS ecosystem, followed by Aramis and a lot of different storage joint ventures, a liquid CO2 terminal enabling gaseous and liquid CO2 transport and storage. The SD++ subsidy and also the position of the KGG ministry, they were really crucial in making this happen. And so we see that many countries in Europe are quite envious on how this works and they want to learn from it. And sometimes they say, we would like to have a similar structure in our country. The policies on a European level were also crucial. So the Industrial Carbon Management of February last year, the Net Zero Industry Act, gave a strong push for CCS, and also the European subsidies like the Connected Europe Facility and Innovation Fund. So we also disseminate our learnings and experience by capacity building. We do that together with the Global CCS Institute and also via the projects network with the Zero Emission platform to disseminate our experiences. Now, it's always better to give a positive message, but I must also conclude that there are quite some worries currently, not directly related to CCS, but certainly influencing CCS. That's the high energy prices currently in Europe, and our energy intensive industry is struggling. And it is important that we keep the momentum, and hopefully we'll get positive support from the Clean Industrial Deal, which is about to materialize. And with this, I would like to end. Thank you very much.
So what I would like to do in the next 10 minutes, I'm not muted, spend some time to discuss the results from a study that we recently completed, whereby we looked at opportunities, export international opportunities for Dutch organizations active in the CCS value chain. So what I will do is I'll give you first a summary of the study in terms of what we've done and why we've done it. And then indeed I'll conclude my presentation with some sharing of conclusions from the study, as well as recommendations we made on behalf of this study. So like I promised, first of all, the why we did it and what we did it. Now, I think also after Stijn's presentation, we'd like to say in the Netherlands, we're one of the front runners when it comes to CCS developments. And we actually have a belief that there might even be export opportunities to build a new Dutch industry aimed at exporting these services, knowledges, CCS technologies, so to say. And the study was really done to basically explore if these opportunities exist and what such a Dutch export industry could look like. Now, we basically had as I said, it was a fairly small study. The approach was like 2 work packages, I would say. The first one basically was getting an overview of what the active Dutch CCS ecosystem would look like, so to say. So we kind of mapped out indeed the different organizations playing in this value chain, either Dutch or non-Dutch with an active presence in the Netherlands. And then the second part of the study was more a desk study, a literature review of a market mapping of these international opportunities. So on the basis of 4 criteria, we basically looked at all areas, all parts of the world in terms of finding an attractiveness, I would say, for these companies to export their services. Now, what were these 4 criteria? The first one was, is there actually CO2 storage potential available? The second one is there industry? Are there CO2 emissions, so to say? We actually also looked at potential opportunities for negative emissions in the forms of BECCS and DAC. And then the third criteria was what's the policy like, the CCS policy and the regulation? I mean, if it's forbidden by law, then opportunities obviously are limited. And then last but not least, what kind of market matureness and market development can we see? And what's the public perception of the CCS technology in that particular area? So this is what we did. Now, what did we see from the results? When it comes to the Dutch CCS ecosystem, I think indeed it's fair to say we already have an active organization in place. We mapped out about 60 organizations basically covering the entire CCS value chain. However, also with the disclaimer that this list is not exhaustive. I mean, and like I said, we have a decent understanding of companies that are out there, but actually the last a couple of weeks, I learned so much about new companies that weren't on my radar either. But again, it shows there are organizations active in this field in the Netherlands, like I said, that are of interest for export opportunities. Like I said, list anyway is dynamic because what we see is players, either new or established, are entering the market and others are leaving these market opportunities. Most companies, fair to say, they play in one step of the value chain, but there are some organizations like a Shell that actually plays in this different parts in the value chain. So they're both a capturing as well as a store operator. Then in terms of mix, now it's actually a nice combination. There's SMEs, there's governmental, non-governmental. And yeah, in our list, it was a little bit more dominated by large multinational corporations. But again, I'd like to make the disclaimer that this list is not exhaustive. I do, at least that's what I thought was interesting. The number of SMEs, it's clearly out there. Quite a few of them are like startups, so definitely an important part of our value chain / ecosystem, I would say. Then in terms of platforms, networking existing, I mean, obviously CATO is one that already works with a CCS ecosystem. Other ones are Task Force Negative Emissions, the CCUS Alliance. What we noticed is, collaboration already exists. However, it's more focused on either research and developments, or it covers a part of the value chain, and limited in the field of business opportunities and truly working on joint projects together. So that's when it comes to the ecosystem. If we then indeed take a closer look at the market mapping of these international opportunities, I think indeed what we concluded is there are basically market opportunities in all areas of the globe. If we look at the individual criteria, CO2 storage potential was present in basically all regions. In some it's more limited than in others, and it also within a region differs slightly from for example, if we take Europe already, then you see that there's difference in storage potential. Then on the second criteria, the availability of CO2, I think that's not a big surprise. That is everywhere. I mean, industry indeed emits either acting in the hard to abate sectors like cement and lime, but also heavy industry, steel, petrochemical, and power and energy sectors. You find them all over the globe, and they emit CO2. Hence, indeed, CO2 is available. Also, indeed, looking at the negative emissions in the forms of BECCS and DACCS, there we saw that there's specifically interest in the more developed markets like Western Europe, Canada, US. So on the longer term, opportunities for BECCS and DACCS, implementation development seem to be more in the developed market, whereas the potential for implementation project could be large on a much broader scale, so to say. Policy and regulation, similar story, have very well in place in well-developed markets, and indeed still, halfway or even lacking in other areas of the globe. And the same conclusion can be drawn in terms of the development of markets. And when we indeed when we try to kind of classify these markets, we say, okay, you have developed market where there is already CCS in place, there are capture projects, TNS projects. So in that sense, one knows the technology, so to say. Then there is, and those are typical US, Australia, Canada, you name it. Then there's developing markets, so that are basically starting to really, accelerate CCS as a technology to decarbonize. And then last but not least, the markets with longer term opportunity. And then I'm more talking about African countries, Mexico and whatnot, so to say. And then indeed, and that's an exercise we're going through now, is what is actually your most attractive market opportunity? Should that be in an established market like developed, but where there is already competition, or is actually developing markets of more interest? And that brings me indeed to the conclusion and recommendations of this study. So like I said, the summary of conclusions, I already mentioned it. So we do have a CCS ecosystem in place. Has significant size all over the value chain, so to say. Also, when it comes to platforms, there are existing platforms in place, but they either focus more on innovation and knowledge, like the CATO, or only cover part of the value chain. So we've noticed collaboration really on business opportunities. Is limited within these ecosystems. And then, like I said, global opportunities, I mean, we actually made a dashboard with coloring, and basically all regions of the world showed some green colors, I would say. So the recommendations that we made, and like I said, we're now basically in progress of acting on them. On the basis of this study was, first of all, validate indeed this small study with the ecosystem. And as a matter of fact, last week when we had another CATO event, we hosted a workshop in the afternoon where we indeed validated these findings in terms of opportunity, but also use that opportunity to really understand from this group of organizations. So what are the challenges that you face? What's the value of such a network? How should we support it? And like I said, to really now work with the industry together, if there is indeed like interest in kind of collaborating on a business level in that sense, so to say. So like I said, that is currently in progress. And then some other recommendations that we made were, one of them was like, yeah, basically, like I said, this was a fairly small, quick study. It would benefit from a deeper dive. So we thought there might be opportunities to just pick a few companies, maybe a few countries, and do a deeper dive on the opportunities to really understand what's the value proposition, quantify the market opportunity. Like I said, this was really high-level screening of. And again, to really make a decision in terms of investment, you need to have some more concrete numbers, so to say. And then last but not least, like I said, we're starting this exercise as CATO. We're not planning on being a business platform moderator, so to say. So we're slowly starting conversations with other organizations who might be have more equipped and have more experiences with exporting opportunities for the Dutch industry. So we also recommend indeed doing that at a later stage, and then eventually also who are already on board, but get more governmental involvement, so to say. So that's when it comes to indeed the study. Like I said, I think an interesting study with promising results. And like I said, one of the players in the ecosystem that we identified is an organization like Carbon Collectors. Like I said, there are many like them in our Dutch industry. So with that being said, I now would like to hand the word to Haije, who's going to talk a little bit more about this organization and the challenges and opportunities of shipping CO2.
Thank you, Brigitte. I actually do like to believe that we're unique in the solution we're offering, but let me share my screen with you all. You should be able to see my screen now. Yeah, thanks very much. Right, so my name is Haije Stigter, Technical Director, Carbon Collectors, and thanks for the invite, Brigitte. We've been speaking on several occasions. Actually, we're leading up to this webinar, and we're quite happy to share our solution with the audience. But before I start, I guess, it's not a check question, but we all agree on the need of CCS for the hard-to-abate industries and to meet our climate goals. And this goes beyond net zero. We actually need to achieve negative emissions. So therefore, CCS is virtually a no-regret investment. So it's something that not necessarily we want to do, but we need to do. And to put that a little bit in perspective, if you look at a global level in terms of the capture projects that are being developed versus the storage projects that are being developed, and I'm looking at the left side of the screen, then basically you see that storage development is lagging with about 60 million tons per annum with regards to the speed where the capture projects are being developed. However, if you look at the right side of the screen, if we want to achieve net zero, we are about 15 times more lagging behind. We're about 1 gigatons of CO2 per annum behind with capture developing versus storage developing. So there really needs to be a focus on developing stores. So even if you look at innovation-funded projects, and this was published by the European Commission last year, of the 12 projects that have been funded, of the 12 CCS projects that have been funded, there's only one that secured storage. All the others are still seeking or storage that needs to be developed. So I guess the need for storage development is paramount in the whole CCS landscape. Now, a very similar picture to the picture that Stijn has showed. It's actually the same data. This is the stores availability, or the CCS stores availability in the southern North Sea in the Netherlands, with the various projects that are being developed, Porthos and Aramis, that will be pipeline connected. Roughly, there's about 1,600 million tons of storage capacity available in the southern North Sea. The Porthos and the Aramis projects in the various phases will connect about anywhere between 600 and 800 million tons of that storage capacity. So there remains about 800 million tons or gigatons of storage capacity available to be accessed by other means than a pipeline. And this is where we come in the picture, other means being shipping with direct injection offshore. Now, what we offer to customers, and we see as our prime customers the emitters, we offer a waste collection, transportation and storage service using a shipping solution. And at the core of this solution is direct offshore injection and the use of shipping. And I'll talk a little bit more about the transport conditions in the next slide. But obviously, we've done some extensive testing with our solution. We have developed what we call a detachable stern vessel. It's not necessarily a tug-barge combination, but you can refer to it as a tug-barge combination because the DSV, detachable stern vessel, actually acts as a monohull offshore. It does already have an approval in principle, unrestricted navigation, and we've done extensive testing at the Maritime Institute in the Netherlands to assure ourselves that we get sufficient workability offshore so that we can assure high levels of operability and reliability of the solution, which has been validated and verified. So we collect straight from the emitter out of the capture plant, put it in a barge. The barge actually exits intermediate storage as well, so therefore it negates the need for an emitter to build its own storage. Once the barge is full, it will be replaced by an empty barge, which basically secures the continuous capture process, and the full barge will go to an offshore location where we have access to the wells, wellhead manifold wells, and a reservoir for permanent storage. Now, in a little bit more detail, we're agnostic when it comes to capture technology, but we look at, on an emitter by emitter basis, we look at the volume and the composition of the CO2 that's being captured. Then together with one of our project partners, Baker Hughes, we will design a compression, conditioning and liquefaction plant to get the CO2 to our transport conditions. And our transport conditions are at high pressure, some call it elevated pressure, 40 bars and 5 degrees Celsius, which basically facilitates direct injection offshore. Obviously, we'll be looking at taking out or managing the non-condensables and the impurities and in the CO2 stream to make sure that the impurities don't have a too much effect on the phase envelope, nor that it doesn't impact the integrity of our system downstream, and doesn't cause any elevated levels of health and safety concerns to people that need to work with it. That's a different story altogether. We can talk about it a little bit later, but I think it's important to understand that at high pressures, 40 bars and 5 degrees Celsius, compared to 15 bars and minus 27 degrees Celsius, we are more tolerant to non-condensables and even levels of NOx and SOx and H2S in combination with water that potentially could form corrosive acids. A full barge will go transport to an offshore location, where in the vicinity of the offshore location we'll actually place a mooring system. It's a fixed bottom structure with a rotating head. We basically moor the tug barge at the offshore mooring system. We establish an offloading connection and an electrical connection because we drive the injection pumps that sit on the offshore mooring system with power that's available from the tug, as we don't use the bow thruster anymore. We are connected with a short flexible flow line to a host facility, and on the host facility all we need is access to the wellhead manifolds and the wells. If need be, we can even sail to a user. So we've basically got a very scalable, very flexible solution. And I think I want you to understand as well, our standard barge contains 5,500 cubes of CO2. We effectively inject 4,000 tons of CO2 per shipload, but with a modest fleet of 3 barges and 2 tugs, we can move about 1.5 million tons per annum. So we can actually simply scale that by expanding the fleet. Now, our client base and there's sufficient demand for our services is all across Europe, whether it's coastal located or inland located. We've actually downscaled our solution to go upriver and on road and rail as well. So we can basically unlock any stranded emitter, if you want to call it that way. Those volumes would be aggregated in a port where we basically transfer it to our seagoing solution and bring it to a store. And I talked about Dutch stores, but England even got more storage capacity available. Danish stores are potentially available as well. So, but as I said, the key remains that development of storage capacity is lagging behind the development of the capture or the CCS technology. Now, this is a little bit of an artist impression of the offshore solution with our detachable stern vessel at the offshore mooring system in the vicinity of an offshore platform. Now, one thing I do want to mention is that Stijn basically talked about the impressive scaling of from staff in a couple of years' time from 70 to 300, and most of them being involved in CCS. And as one of the reasons is that the permit application process, I mean, not only the permit preparation, which takes about a year plus, then the evaluation of the permit could take another year to 18 months. That actually sits on the critical path of developing most stores. That's actually a call it a decelerator when it compares to when it comes to stores development. So I think if we collectively look at seeing whether we can accelerate development of the stores, that's one area I think we need to look at. I did talk about our transport conditions, 40 bars 5 degrees Celsius, that facilitates direct injection. All we have to do is increase the pressure to the injection pressure between 80 and 120 bars. Dimension-wise, our ships are modestly, and when it comes to length, 150 meters. It's got a breadth of 16 meters and a draft of 6.5 meters, which basically means that when you look at the map of Europe with those coastal locations, we can access all the locations we've been asked to see whether we could supply our services to. Now, I guess the challenges and the opportunities.
Haije, you have 2 more minutes just to allow indeed the audience for some questions. Sorry for that.
That's okay. This was my last slide.
Okay.
So capacity of the stores being available is lagging behind for the demand of storage capacity that needs to be available. Although we called it CCS in the Netherlands, it's a cross-border challenge. So, you know, I think we need to, when you look at our southern neighbors being Belgium or France, and our eastern neighbors being Germany, which are not necessarily privileged with offshore depleted or a lot of offshore depleted storage locations. That's where this becomes a European challenge and not necessarily only a Netherlands challenge, but I think you touched upon that as well, Brigitte. Timing is important. We see a huge lagging of storage development when it comes to capture development, and we need to close the value chain. And we believe that shipping solutions need to be existing next to the pipeline solutions, and that we need to basically bet on all horses rather than on one. So therefore, I guess our plea is to basically accelerate this development. And this is where I want to leave it. Any?
Perfect. Yeah. So I'll just had a quick look indeed at the Q&A, and I'm afraid indeed we won't be able to answer all questions, but I'm gonna go through it and see where we end. So Stijn, the first one actually for you. With Denmark issuing onshore CCS licenses, do you think integrated industrial plants will become more attractive because they offer more efficient in the allocation of capital and resources?
Yeah, but I think it is always good to integrate industrial plants, like we have in many ports, to exchange energy streams and product streams, which can be a raw material for another. So whether it's onshore storage or something else, I think it's always good to look at optimal integration.
And then I have another one for you. Quite a few UK projects are aiming for depleted gas fields too. We now see the highest risk evaluated in depleted gas fields. How do you look at that? Like aquifers versus depleted?
Yeah, that is a lot of discussion in EBN as well. Basically, aquifers are higher in pressure, so you have potentially less problems. The point is, with depleted gas fields, we have got decades of operational data, and that helps us in making the storage permit application ready. While for aquifers, you need to do much more research before you are able to get to a storage permit application. So one can be realized on short term, has potentially some risk with respect to injection. That is the depleted gas fields, but the other one will take much more time to mature. So I think you need them both. And yeah, in the Netherlands, we have chosen to first take the depleted gas fields, but we're also looking at aquifers.
Yeah. And then I also have an interesting one for Haije, especially relevant for offshore injection. Can you elaborate how you manage intermittency in the direct injection?
Certainly, and I've seen a related question to that as well. And that's the reason why we landed on the 40 bars at 5 degrees Celsius. And that's the reason why I think somebody else mentioned, Northern Lights or green sands actually need to recondition or their CO2 before they inject it, but they transport it at 15 bars and minus 27 degrees. Obviously, we've looked at the whole flow assurance thing or issue or challenge in the well, where you do get some Joule-Thomson effects because of the intermittency, but it's very limited and for a very short period of time. And we don't see any extreme low temperatures where we are concerned about, having to use materials that can actually manage extreme low temperatures. So it's been studied, it's been validated, it's been verified. EBN actually has also looked at the work, and TNO has looked at the work we've done when it comes to flow assurance. So we don't have any issues. But it is a combination of well design, making sure that you create sufficient friction in the well to make sure you don't get extensive expansion or Joule-Thomson effects in the top of the well.
Yeah. Just one question for you, Haije, just to finish it off, because as I said, I know this is extremely relevant in terms of CO2 quality and composition. So will you be cleaning the CO2 to a uniform composition no matter what the sources that you collect it from to ensure consistency with CO2 composition at different stores?
Well, no, we won't. So we will we condition the CO2 to those conditions that we can tolerate. And as we operate at and transport at high pressures and temperatures, we can tolerate more non-condensables. And we don't put specific limits on the non-condensables, but we look at the cumulative effect of the non-condensables on the phase envelope. And we allow for a 1.5 bar shift at 5 degrees Celsius. NOx and SOx and H2S in combination with water is not necessarily an issue, but needs to be looked at on a case-by-case basis. We dehydrate to single digits, therefore also making, again, under the higher pressure conditions, the NOx and SOx tolerances are higher. And then thirdly, we look at if there's anything that could have a potential health and safety impact on individuals working on the ships. Think about H2S. That the H2S concentration, the H2S in the CO2 cannot have a larger health effect than CO2 by itself. But so we're not necessarily moving towards a uniform spec, because then you need to default to the lowest tolerant spec, and then you default to not even medium pressure, but even low pressure. We are aware of the discussion between Porthos and Northern Lights, but our specs are more tolerant than the others.
Yeah. Now, clear answer, and that indeed brings us to the end of this webinar. I think a very interesting webinar. Like I said, we'll have a closer look at all the other questions and share them with the presenters in terms of getting back on answers. Leaves me indeed with thanking Stijn and Haije for their contribution. As I said, very much appreciated. And I see indeed the slide from Keris basically announcing our next European webinar series by the UK CCS research on April 7th. So they will be talking about CCUS developments in the UK. So with that being said, I'm wishing you all a very good remaining of the day and hope to see you next time. Bye-bye.